Greetings to all the viewers. The session is going to deal with defluorination by using Nalgonda technique, right? So, as we already aware, fluorinated water will cause so many kind of dreaded diseases, right? So, if the fluorine content is higher in the water, that water, if consumed by the people, that used to induce the disease called fluorosis. The fluorosis is the disease which is related with decay of the tooth and decay of the bones are possible, deformations of the bones are possible, and even it can be transmitted from one generation to another generation as well. So that highest fluorine content in the water will cause so many adverse effects to the people. Normal survival may not be possible if fluoride content is larger in the water, right? So if the certain extent of rise in the fluoride content in the water, that used to give the stains on the teeth, that is the symptom to identify there is a certain extent of fluoride content in the water, so that we need to go for the removal of that one. If the concentration is still higher, that may cause the weakening of bones, weakening of teeth as well, and that may cause the failure of bones as well. So that's the reason why defluorination is very essential at the higher level of the fluoride ion if present in the water. That is the simple technique is Nalgonda technique taken for the consideration, right? So here this is the content which is taken as the part of water and its treatment. It is the part of engineering chemistry chapter 1, water and its treatment, that defluorination Nalgonda technique is going to be discussed. So here earlier also we conducted series of sessions based on this kind of water and its treatment. All are available at Dr. KAVITHA Chemistry Academy channel, and you can subscribe the channel, share with your friends, and watch regularly, so that we will get the new content updated one every day, and it will be most beneficial for your preparation. And not only this one, competitive based chemistry, research based chemistry, conceptual based chemistry also available at the channel Dr. KAVITHA Chemistry Academy. This is the content what we are discussing was taken from textbook of engineering chemistry authored by Dr. Kavitha Kottireddy Kota. Let me introduce defluorination by Nalgonda technique. Nalgonda technique involves the rapid mixing of chemicals with water where the fluoride content is high. That fluoride will be converted into a kind of flocculation, sedimentation. So whenever flocculation taken, coagulation taken, and that is further sedimented, meaning precipitation taking place, and simply it can be filtered, and disinfection is also carried over there. So these are the very important steps taken in this defluorination by Nalgonda technique. Olums are especially used for this flocculation process. Flocculation means for the coagulation. Whatever tiny solid impurities are present, whenever olums are added, all got aggregated, and the size of particles got increased, and they get simply precipitated at the bottom. This is the way olum efficiently works for the removal of such kind of fluorinated water. So the fluoride content which are present in the water, so that the colloidal sized particles now becoming precipitation. Precipitated particles are very larger, easily identifiable, and simply filtered, and disinfection is also carried, being water is the source of so many pathogenic microorganisms like bacteria, virus, fungi, protozoans, etc. That's the reason why disinfection also requires, right? The process is best carried under alkaline conditions. It is more effective. Defluorination by this olum process, Nalgonda technique, is more effective when basic conditions are present in that. That's the reason why intentionally we are adding lime to that one. Lime is nothing but sodium carbonate. When lime added to the water, that used to remove the excessive fluoride ion very efficiently, being alkaline conditions are suitable for this Nalgonda technique. For disinfecting, bleaching powder is sufficient. Bleaching powder is calcium oxychloride, Whenever it is added, that is releasing hypochlorous acid, which is the better efficient disinfectant used to kill the pathogenic microorganisms. After stirring, chemical elements are coagulated. Coagulation process is nothing but the tiny particles got aggregated and the size will be enhanced, and simply that will be sedimented at the bottom. Advantages of Nalgonda technique, or it's a simply adoptable. Even for the domestic purpose, you can simply use this kind of Nalgonda technique without any proficiency, without any sophistic and scientific gesture, right? So bleaching powder can be used. So they may contain some disadvantages as well. For all pH, they may not be sufficient to use, and fluoride ion concentration is extremely larger at the condition. Nalgonda technique may not be applicable. So apart from that, it is more convenient and suitable for the removal of excessive fluoride content present in the water. Silent features of Nalgonda technique are Nalgonda technique is easily adoptable and you can use at domestic purpose. Organic contaminants present, any colored matter is there, any foul odor present in the water, any turbid material is there, simply removed by this Nalgonda technique. Right, so alums are very efficient and repeatedly you can use, so that need not to buy alums every time, rather they can be repeatedly utilized for this removal of impurities from the water. Handling charges are extremely less, and alkali solution is very required, and proficient people may not be required. Normal people can operate this kind of Nalgonda technique. Need some minimum mechanical and electrical equipment. By using normal domestic utensils only, you can simply go for this Nalgonda technique for deflourination method. Highly efficient for the removal of fluoride at the range of 1.5 to 20 milligram per liter. At this condition, fluoride content will be easily removed. Determination of fluoride, we are using ion selective electrode. Ion selective electrode is more suitable for the detection of fluoride ion. If fluoride ion content is known to you, it's obvious to go for the alum treatment, so that fluoride will be simply removed by this Nalgonda technique. Ion selective electrode is specific for the detection of the potential by specific ions only, like fluoride. So fluoride ion can be measured by using lanthanum fluoride solid state electrode that is specific for the concentration of fluoride ions only. And these fluoride ions are able to give the potential, so that you can identify the concentration of fluoride ions. Ion selective membranes may be glass or crystalline. They are made up of inorganic materials, and even organic ion exchanges can be used. Membrane interact with the ions of choice like fluoride, so that electrical potential will be generated at that instant, so that fluoride ion concentration can be calculated. Potential of ion selective electrode can be measured by means of pH meter. So here the formula for the calculation of potential for the fluoride ions. Here the E cell is equal to standard electrode potential plus 2.303 RT by NF log of concentration M. Here N denotes the charge present on the ions, and M here, in case of this one, fluoride ion concentration can be taken. The equation is valid for the dilute solutions, more effective. If the concentration exceeds, it is not feasible to detect its concentration. In this experiment, fluoride sensitive electrode is taken as one of the internal electrode, and external reference electrode might be columnar electrode or silver chloride electrode can be taken. Ion selective electrode specific for the fluoride ions, so that fluoride ion can be easily detected, measured. Sorry, potential can be calculated. Here the requirement of the reagents are sodium fluoride is required. Dried sodium fluoride at 100 degrees centigrade for the period of 1 hour is required. Potassium chloride is required. Liquid sodium fluoride is also required. Ion selective electrode, one is that is lanthanum fluoride. Solid state membrane is required. In either external silver chloride electrode is required as a reference electrode. First of all, We need to dry that sodium fluoride for 1 hour at 100 degrees. Next, sodium fluoride stock solution is prepared. 0.42 grams of sodium fluoride was weighed, and that is added with 100 ml water. Later on, 10 ml of the stock solution was taken, and 100 ml volumetric flask deionized water will be added, so that you are diluting the solution. Potassium chloride 1 molar solution to be prepared. For that purpose, exactly 7.55 grams of potassium chloride weight and 100 ml of deionized water will be added. Deionized water means water without any ions in that, water free from the ions, because any ions if present, that also give the reading, different readings we will get. In order to avoid that one, so here specifically deionized water can be taken for this purpose. Here, whatever standard solution we prepared, 100 ml volumetric standard solution we prepared, that is sodium fluoride. So 4 different containers, 4 different volumetric flasks were taken. In each volumetric flask, you are preparing different concentrations by different dilutions. 4 standard flasks made with different concentrations of sodium fluoride solution. Now, it's time to go for the analysis process. In order to analyze, we have this deflourination by determination of fluoride ion concentration by using ion selective electrode method is possible. The electrode which is selective for certain ions potential and applied for the determination of electrode potential, the strength of selective ions are detected, that is called ion selective electrode. If you are taking mixture of ions, if you are placing ion selective electrode, that will read the electrode potential of only specific ions, that is called ion selective electrode. For the determination of fluoride ions, we have lanthanum trifluoride. This is a specific electrode for fluoride ion concentration measurement. Method of fluoride ion determination. Log of concentration of fluoride ion can be taken on the x-axis, and y-axis millivolts values, whichever measured on the potentiometer, can be taken on y-axis. The concentration terms of unknown solution of fluoride ion also measured. That is also plotted on the graph, so that you will get a straight line with a positive slope, and all the concentrations to be taken in parts per million values. And commonly used ion selective electrode is solid state ion selective electrode, and that is lanthanum trifluoride. Then here another important one is TSAB can be added as a adjustment buffer. This TSAB buffer used to avoid the interference of metals. Here fluoride ion selective electrode, solid state electrode was provided over there. Always, in order to measure the potential difference, 2 electrodes must be inserted into the sample solution, right? One of the electrode is said to be a reference electrode. You may go for silver chloride electrode, or else calomel electrode as well. And another important electrode, ion selective electrode, you can clearly observe over here. This is very selective for the fluoride ion concentration. The electrode structure is provided at the bottom. You can notice that lanthanum fluoride membrane that is present over there. Whenever these two are inserted, fluoride ion potential difference can be measured by using potentiometer, right? How to do the experiment? Initially, 100 ppm standard stock solution got prepared, as we already know how to prepare that solution. Earlier we discussed. Take the great care during the preparation of the solution. Sodium fluoride solution you are preparing, that is the standard solution, that is the stock solution. It's not preferable to store the fluoride ion solution in the glass container, because whenever glass container is added with the fluoride ion will react with the glass. That is called etching of glass. In order to avoid that one, glass containers may not be used for the storage purpose. 20 ppm of fluoride ion standard solution was prepared, and 10 ml of TSAB solution is added. This is the buffer solution. And here standard sodium fluoride solution. From the standard sodium fluoride solution, you are preparing this 20 ppm fluoride ion standard solution. So series of fluoride ion concentrations were made, just to be discussed, 4 different concentrations to be prepared, and whose concentrations are known to you. 20 ml of sample fluoride ion solution was taken now. Up to this standard solution was taken. Now it is turned to 0.5 indicates 20 ml of sample fluoride ion. Whose water fluoride ion you want to determine, that fluoride ion sample water was taken here. Right, I'm taking mouthwash. So in that mouthwash, how much fluoride ion is there to be identified? So 20 ml to be pipetted out, 10 ml TSAB will be added, and that is made up to 100 ml solution with a distilled water. From that again, you are pipetting 20 ml of the diluted solution into the beaker. Now, pH is required to be adjusted. The ambient pH level is 5 to 9 pH is required. Fluoride ion selective electrode, individual beakers will be taken and individual potential difference you are measuring. These electrodes are connected with pH meter and potential is also calculated. pH is required to be calculated, potential is required to be calculated at various concentrations. How to do the experiment? So here ion selective electrode calibration is carried by pH of higher concentration first. Higher concentration calibration taken, later on lower concentration. Known and unknown concentrated fluoride ion pH values to be measured. Potentials also labeled. Parameters to be tabulated. So in this table, serial numbers, how many experiments you are doing, those many numbers will be taken. What are the pHs of various solutions you prepared? Standard solutions are of different concentrations, right? So at the different pH values also present. That's the reason why different pH you can measure. They can be tabulated over here. And individual concentrations also known to you. Those concentrations can be taken in the third column. Then all the concentrations are placed on the logarithmic table so that log of concentration can be taken as the fourth column. And millivolts, potential difference values are measured and molarity also calculated. This is about the data tabulation. After getting the data, it is time for the graphical representation. Log of concentration of standard fluoride ion solution was taken in the x coordinate and the potential difference in the millivolts values taken in the y coordinate. If you are measuring all these values, you can put the dots and the dots connected with the straight line with a positive slope. So after getting this one, so unknown fluoride ion sample solution will be there. So whose concentration is not known to you, but whenever it is placed in that potentiometer, what happens? It will give certain reading. For example, it is giving the reading at this point. This is the reading of unknown fluoride ion sample solution. Obviously, whose fluoride ion, whose potential is known to you, if you are extrapolating the line over here, so that it is possible to calculate its concentration. In this manner, how much fluoride ion is present in the water sample can be easily identified. So graph is plotted between log of concentration of fluoride ions on the x-axis taken in the ppm and millivolt values taken in the y coordinate, and the entire experiment carried at 25 degrees centigrade. Unknown fluoride ion, when experimented, solid state ion selective electrode is selective for the fluoride ion determination. That the known potential value you got it. From that known potential, you can extrapolate so that unknown fluoride ion concentration is identified. This is the way from the graph only you can identify the concentration of unknown fluoride ion sample solution. So if it is known to you, it is obvious to go for that removal of fluoride ion by Nalgonda technique. Alums can be added, bleaching powder can be added. Alum used to convert the entire fluoride into the precipitate. You can simply filter that one, and also bleaching powder used to disinfect that entire sample so that microorganisms also removed. This is the way deflourination is carried by Nalgonda technique, and determination of fluoride ion concentration by ion selective electrode is possible. Two different topics got covered over there. Hopefully you understood the concept, and detailed information is provided over there. You can subscribe the channel, watch regularly, share with your friends, and we will get the updated content every day. Definitely you will get the success in your field. Signing off, Dr. Kavitha Kottireddy Kota.